Okay guys, in this session we're going to talk about how to calculate the shear stress and size of a weld. And we're going to be referencing some of the information from Shigley's book, as well as information from our statics and strengths classes that we've had. So this is going to be not that hard of a problem to approach, okay? And we'll get you some of the tables and stuff that you need for this. Now, let's look at this. This is the problem statement here, what we're given. We're going to have a beam right here, and we're going to weld a plate that is A36 steel, half-inch thick plate. We're going to weld all the way around, so we're going to weld all the way around here, and even on the back side, a 1/4 inch fillet weld all the way around this thing, allowing us to put 10,000 pounds of force on this. We're going to pull on this, and hopefully we don't shear and break loose these welds through that effective throat area. So we want to find the stress in the weld. Now, let's stay focused here. Allowable shear stress is going to be equal to tau, okay, that's shear, okay, equals force divided by, now where's this 0.707 H coming from? Remember we talked about the leg of the weld? That's your H, so 1/4 inch, right? And we wanted that theoretical throat. We said it was a 45-degree angle. That's sine or cosine of 45 degrees is 0.707, so that's why I just put 0.707. In a lot of the books, they'll just have that value there, times the length of the weld. So we have 2-inch long welds here, and there's 4 of them, so we got quite a bit of length there. So let's go fill all this stuff out. Force is 10,000 pounds, 0.707. We talked about the leg of the weld being a 1/4 inch, and show your units, and then you have 4 times 2. We got 4 welds at 2 inches each all around here. That's going to give us 7,700 or 7,072 pounds per square inch. This is lower than the allowable stress for that electrode. Now, how do we know that? Okay, in this table right here in Blodgett later on, and we'll have these tables for you guys, and you have it right here in front of you. Basically, what they're going to have is our base metal, A36 steel. We're using an E60 electrode right here, and it says the allowable shear stress in the weld is 13,000. So this thing is going to hold up. This weld is probably a little too big for this, okay? But that's okay. It's not going to break. We've got some safety factor in there, don't we? Okay, we could use this and find out what kind of safety factor we have going on there. Another thing they like to do is do allowable force per inch of weld being at 9,600, and you'll see that in other calculations down the road as well. So from this, what we're going to be doing in lab is we're going to be welding some coupons, putting some load on there, putting the weld in shear stress, and you guys are going to have to do some basic calculations of force and stress. You may have to do a little algebra here, but this is the basic equations. Again, not really that hard to size the weld for this. And talking about sizing the weld, if we were given this problem and looked at it from a different angle and said, hey, size the weld. Okay, here is our force in shear. Okay, now where did we get that at? Let's go back here. Remember that allowable force right here, 9,600? That's where we're getting that value there. Okay, we're going to remember that value. That's the allowable force of 1-inch weld here. So what we want to do is get the shear force for this right here, this weld, and we're going to take the force divided by the length of the weld. So we can take that 10,000 divided by the length of the weld, which we have 4 of them at 2 inches, and that comes up to right here 1,250 pounds per inch. If I take that shear force right here, 1,250, and divide it by that table that we got down here, correct, the 9,600, and I divide those out, it will give me the weld size that I need, because I'm left with nothing but inches when I divide this out. It will tell me that I need a 0.13 inch size weld, which is 3/16, which is smaller than what we saw in the previous problem of a 1/4 inch. So we could actually go with a smaller weld on this. But again, we would want to think safety factor and not design things size for one. So you kind of saw 2 different approaches of the same problem, finding the shear force inside here, the shear stresses, I should say, and then also coming in here and looking at the weld size for the same type of application. So between these two, you should be prepared for lab.